This is 7.2 for Pre-Cal 11. This is all about compound interest. Probably a much more useful formula and calculation for you guys, especially in about 2 years when you go off and start getting college loans or buying cars and houses and that kind of thing. The formula for it is A equals P times 1 plus I bracket to the power of T, where A is your amount in dollars, P is your principal, I is the annual interest rate as a decimal, same as last time, and T is the amount of time in years. Again, it's a formula and it's all about manipulating and plugging in the formula. The real trick here is understanding what and how to put in certain values. So, a principal of $3,350 is invested in a savings account that pays 3.65% interest compounded annually. What is the amount of the interest after 8 years? So the difference between simple interest and compound interest, or really what we used to do in a final if you had the two, as soon as you see the word compounded, you know it has to be compound interest. It sounds kind of simple, but if you don't see that word, assume it's simple interest. Always start by writing out your formula. You're not required to memorize these formulas. You are given them if we're on a test or a final, but they will not explain which one is which, so you have to understand which one is simple versus compound interest. It is then always good practice to then give yourself a bit of a legend of what each of these values is. And the real trick with always doing this is if you always do this, even if you have no idea what you're doing, you can start filling in your information. You can fake it till you make it, because if I see you filling out things like this, and even if you get halfway and you stop, I'm probably going to give you half marks because I assume you know what you're doing and you're following the right steps. We don't know the amount. We know that the principal is $3,350. The interest rate is 3.65%. So again, we want that as a decimal, so we're going to divide it by 100. So really it's 0.0365. And our time is going to be 8 years. We're now just going to fill in our formula. A equals 3,350 times 1 plus 0.0365, all to the power of 8. The real trick with these formulas is just remembering following operational orders, or BEDMAS. So we're going to do our brackets first. So 1 plus 0.0365, add that first. We're then going to use that to the power of 8. Depending on your calculator, for mine it's this little up arrow key here, to the power of 8. Then we're going to multiply that by 3,350. So we know that after 8 years, the total amount, including your principal, was $4,462.71. Now in these situations, if you're just asked to find how much interest you earn total, you would then take your principal and subtract it from your total amount. But more or less worried about that. Compound interest is nice because for every compounding period, the money you make also gets added to your principal, so you're essentially going to be making more money on your principal as you go, and the money should get more, and you gain a lot more money than simple interest. Well, maybe not a lot more money, but you gain more money. Most of the time, compound interest is not calculated in a yearly basis. It's per compounding period. Basically, however your payments are set up or how often it's meant to compound. This slightly changes our formula. We're doing the exact same formula, but we're adding n into the equation. And n is basically the number of compounding periods in a single year. So let's say a equals p times 1 plus r divided by n to the power of n times t. Everything else is the exact same. A is the amount, P is the principal, R is the annual interest rate as a decimal, and T is the number of, or is the time in years. It does change up your formula slightly when you solve it. So if we had a principal of $6,250, it's invested in a savings account that pays 1.75% compounded interest monthly. The key point there. How much is the account going to be after 6 years? So Like everything else, start with your formula. And it's always good practice to then fill in all your unknowns, just so we kind of know what the heck we're dealing with. We don't know what the amount is. We know the principal is $6,250. Your ratio or your rate is 1.75%. Divide it by 100 to get it to a proper decimal, which is 0.0175. N is the number of months. So if it's compounded monthly in a single year, basically for every month in that year, it's going to compound. So really that is 12. Okay? Or 12 occurrences per year. And our time is going to be basically still in years, so we're dealing with 6 years. When we fill this in, A equals 6,250 times 1 plus your rate, which is 0.0175, divided by 12 to the power of 12 times 6. Again, following BEDMAS rules. I'm going to go inside my brackets first. I'm going to divide before I add. So 0.0175 divided by 12 plus 1. So A equals 6,250 times 1.00145, and I'm going to keep this and float this in my calculator, to the power of 12 times 6, which is 72. I'm going to start with my internal, 1.00145. I'm going to take that to the power of 72. Again, exponents before we multiply. And now I'm going to multiply by that by 6,250 to get a total amount of $6,941.41. So even after 6 years, 1.75% compounded interest, the person's only making close to $600. Not a whole lot. This one's a bit of a longer one. So, you're going to invest $2,200 for 2 years and earn $196 in interest. If the interest rate is compounded quarterly, what was the interest rate? A quarter means like 1/4, really. And if it's compounded quarterly, it means it's happening 4 times per year. That's kind of important information. Now the formula you'd probably jump to right away is A equals P times 1 plus R over N to the power of N times T. The issue with that is we actually don't know A. We know the initial investment and we know how much we made in interest, so technically before we can solve this we have to solve for A. Luckily for us, the formula to solve for A is rather simple. So we're going to fill everything in first. A will go P, R, N, T, and I. We know the principal was $2,200. We know the rate. Actually, we do not know the rate. We got to figure that out. We know that N, which is the occurrence, would be quarterly, which means it's going to occur 4 times per year. And T is the number of years, we know is 2. The interest rate itself, we made $196 in interest. So to first solve for A, to fill into this formula here, we first figure out P plus I. Basically 2,200 plus 196. So we know that A is really 2,396. Now that we know that, we can use our first formula. So A equals P 1 plus R over N to the power of N times T. start filling things in. 2,396 equals 2,200 times 1 plus, we do not know what r is, but r is divided by 4 to the power of 4 times 2. Our goal is at the end is going to be to isolate for r. So I'm going to first, because we're multiplying here, I'm going to divide both sides by 2,200. And I'm going to float this in my calculator to make life easier. So 1.089 and some change equals 1 plus r over 4, and 4 times 2 to the power of 8. Now whenever I want to get rid of an exponent, I take the corresponding root. So if we're taking to the power of 8, we're going to take the 8th root of each side. And when we do that, it's going to cancel out. The 8th root of the following should be 1.01 and some other things. This is going to equal 1 plus r over 4. We're slowly breaking things down as we go. I'm going to subtract 1 from both sides. And again, I want to, even though I'm not writing down all the digits, I am keeping this decimal as long as I can in my calculator, because if I just rounded this off, it's going to completely eliminate your entire answer. But I am going to subtract 1 from both sides. So we have 0.010725502 equals r over 4. To get rid of division by 4, we multiply both sides by 4. So we know that the rate was 0.0429. And if you wanted this as a decimal, rather than divide it by 100, we're going to multiply it by 100, which means our percentage rate was 4.29%. The math and the algebra isn't too bad, there's just a lot of it. Last part is called the rule of 72. Kind of a simple concept. It's going to be a rough estimate for the time and years it takes for your investment to double. It's equal to 72 divided by your annual interest rate as a percent. So where every other time right now we've turned the percent into a decimal, and I just leave it as a percentage. So approximately how many years will it take to double an investment that earns 5.2% compounded annually? You put in 72 divided by 5.2. It's about 14 years. This works for almost all interest rates. It's kind of interesting. It's not super accurate, that's why we call it an estimate, but it gives you a rough idea. Your questions for Google at 7.2, there's only 2 of them. The first one is, you have a principal of $10,000. It's invested at 3%, that interest is compounded annually. How much will be in the account in 7 years? And your last question is, how long will it take for an investment of $1,000 to hit $2,000 if it earns 0.5% interest that's compounded annually? Think of the rule 72 for this one. Other than that, if you have any questions or concerns, I'll be online Tuesdays and Thursdays for tutorial. Good luck.